Hi, my name is Augusto Jang, and this is my lab report for Lab 4 for Physics 2211. As for the introduction for this lab, our goal was to model and analyze a spring mass system that is moving in two dimensions, specifically the x and y coordinates, from the video that was given. And our goal was to compare this with our computational model in Python. So the motion from the video was extracted using Tracker with its respective calibration sticks and other calibration tools to define the origin. And we attempted to simulate the same motion in Python. And some key values that were given were the mass, which was 0.402 kilos, spring stiffness constant, which was 6.83 Newton meters, and the relaxed length of the spring, which was 0.123 meters. And as for the experimental method, I said before, Tracker was used to extract the position of the mass, and we disregarded the z-axis, and as you can see, graphs and data points were made in Tracker. So the top graph being the x position versus time of the mass of our video, the second graph being the y position versus time, and the bottom one being the data points that were recorded versus time that were used to convert it into a CSV file to compare with our computational model. As for our computational model, different formulas following physics principles were used to simulate spring and gravitational forces. Initial position was used as the same one from Tracker. Initial velocity was used by subtracting the second data point from the first data point, divided by the change in time. And as said, Newton's second law and Hooke's law were used to simulate the motion and forces in our model. And as you can see from our results, position versus time models, comparing our computational model from our experiment, from our video, as you can see, the x positions were very similar in both, but the y positions were slightly different, where the model had a higher oscillation, but similar periods and similar motion in general. As for the energy graph of our model, you can see how they were all graphed, and change in total energy was 0 as expected because our system was our mass, spring and earth. Surroundings would be nothing, and it just makes sense, as if gravitational potential energy was large, the spring potential energy, was equally as large, while total energy was 0. So understanding our results, the energy principle was satisfied as the change in total energy was 0. Oscillation estimates for the oscillation periods were made, where for the x coordinates it was 1.71 seconds, and for the y it was 1.52 seconds, which was extracted by just finding frames from one extreme to the other in the y and x directions. And greater differences in y position could be due to small measurement errors and assumptions like no air resistance or perfect alignment of the spring. And as you can see, the periods match in both the video and model. Some summary and takeaways. The energy was indeed conserved in our model. The x position was similar in both. Y position was slightly more oscillated of our model. And as a conclusion, the Tracker and VPython R code were indeed a good comparison to simulate real-world physics. And yeah, thank you for watching.